My name is David Rain. I'm with Raveon. Raveon is a manufacturer specific to wireless data modems and radios. Those wireless data modems and radios are primarily used for everything we're talking about at the show. You've probably been looking at everything from the point of transmission of GPS telemetry data and such not. What I'd like to do is give you a little introduction and overview of Raveon, some of our projects, what we've been working on, and then afterwards I'm going to bring up Adam, who's our engineer. He's going to talk a little bit about the technology aspect of that and some of the opportunities and what we're really here for in looking for partners. Before we get started, I'd like to tell you kind of where we came from, because obviously Raveon, with a lot of these other companies you might not have heard of, we've been in the military or the government space for quite some time now. We specialize in manufacturing of products that are used in a lot of the organizations that you see on the screen here, Honeywell, Boeing. We actually do some commercial applications, which would be Toro, MDM. These units are manufactured and deployed all over the world. We have thousands of clients and an ongoing process of OEM for a lot of those clients as well. Raveon is not specific to any one technology, and I think that's where our sweet spot is in the IoT sector. We don't actually manufacture one radio for one frequency. We manufacture a radio for any applicable frequency to your application. So whether you're in an actual city environment and you need something a little bit more resilient based on the large dense area, or you're out in the middle of a desert and you need to do things for mining, we can provide you with the frequency or the equipment that coordinates with that frequency to meet those objectives for your communication needs. A lot of talk about the Internet of Things, as we're all here for, and in that, I think what's not being expressed enough is the diverse amount of resources in the IoT space. For instance, IoT, everyone kind of almost immediately goes to cellular service. So we think first, okay, we need two things to talk, let's just get a cellular modem, plug it in, and everything works great. The downside with that is it's financially impeding in a lot of cases, but more importantly, there's other things that are barriers, such as smaller deployments, again, financially barriers, but contracts, things of that nature. What we do is we actually invoke a lot of different solutions that make up the IoT space to us. For us, the definition of the IoT is really the connectivity. It's not so much the method of that connectivity to a particular protocol. One of the large projects that we're really proud of is working with MDM. MDM Spectrum is actually building what we feel is the first, or amongst the first, we've heard a couple firsts, a lot of firsts here at the show, amongst one of the first national platforms for just IoT. So MDM is actually building out a network of antennas, a network of devices that will be used very specific to the IoT sector. These are device-to-device applications, whether it be for GPS tracking for a utility-based guys company, or even individual use for personal tracking, all the way up to telemetry data for business communications such as HVAC, thermostats, and things of that nature. MDM is building out that structure to support that network for a singular protocol application. That is on the backbone of the LoRa network. Another aspect of that is, because of this experience and some of our projects prior to this, we've deployed in over, I see the numbers here, I don't want to mislead anybody. Let's go to the next one. We deployed in several markets across the globe, not specific to the U.S. in any matter whatsoever. I'm not going to talk too much about frequencies because, to be honest, this is not my sweet point, but this will give you an idea of the range of frequencies that we can develop and implement technology directly with. So our data modems can be programmed or embedded with these protocols that can be then specific to your individual application. So there's no barrier in networking multiples of types of equipment together, or more importantly, restricted to one type of protocol against another one.
We got a question here.
What is MURS, M-U-R-S?
MURS is basically a free, unlicensed band in the U.S. Amateur radio, if I'm not mistaken, was a large user of MURS.
So the answer is to those listening is Mirrors is being used by Burger King. I like a Whopper with that. Yeah, okay. Is that it? Is that right? Okay.
Our Dart is how we manage all of this. Dart is a protocol very similar to maybe Zigbee or what you're seeing in some of the other networks out there. Dart is our proprietary protocol. Dart is a method in which we allow all these devices to communicate in a very functional manner. So they're not stepping on each other. We're not losing packet data when the communication is taking place. More importantly, we can plug in a multitude amount of devices into a single base structure. So we could have tens of thousands, if not hundreds of thousands of devices communicating on the same network through the Dart system. And Dart can be deployed from a very small aspect. Maybe you have 12 trucks, so you deploy the Dart system to manage those trucks in an area, all the way up to you want to do a nationwide network. The Dart would then manage all those devices plugged into it. IoT security is really important to us. It is to everybody here. We use a lot of the standard protocols when it comes to security. I don't want to overtalk or even understate security in any means, but there's a lot of standard protocols already existed, and we don't want to try to reinvent those. We deploy those standards, and we use them on a regular basis. What Raveon is doing at this event here is looking for partners. That's our primary objective. Our goal here at this show is to introduce our technology, our capabilities, and more importantly, our desire to actually build a functional IoT system for everybody to play in. And that's through the manufacture of a multitude of different protocol available devices that all plug and interconnect together. Oh, time. So that's basically our general presentation. We only have a few in the audience.
I got
here.
some questions.
We're going to answer some questions now.
So you're talking. Let's go back to the security slide. Can you do that real quick?
Which one?
The security slide. And I had a couple questions about that. Oh, no, go up one. Okay, it's the pre-shared keys AES 128.256. That's the encryption you're talking about.
Unfortunately, I'm going to bring Adam up for.
All right, Adam, explain that to us.
Yeah, that's the encryption we use. We use pre-shared keys, or we can use a PKI authentication where you negotiate a key and then fall into AES 128.256.
Okay, next question.
Okay.
So we're talking about mirrors, which it seems like anybody in the world could hack. How do you protect a mirrors type environment from hacks?
A mirrors environment is not. It's something that you can do a small scale system on. You're never going to deploy a system where you're going to be worried about that level of security on mirrors.
Okay. Do we have any other questions? What band?
Yeah,
the mirrors band is in the 150 megahertz. It's like 154, 156, I think up to 162. You got 12.5 and 20 kilohertz channels.
What was the question?
Was the LoRa network your newest area? Was that April of this year you're coming out with? Or?
Yeah, April of this year. The Dart network is coming out around the same time. We're doing those in parallel. We're doing the LoRa network as an extension of the Dart network. So the Dart is our cellularized narrowband network for licensed private frequencies, and then LoRa is our offering when you want to use public frequencies.
Any other questions? Okay, I'm sure that Dave and his partner will be here to answer any questions here or at their booth. Thank you so much.